Good afternoon, everyone. 1 o'clock on a Wednesday. Pretty good, pretty good. It's a full house. Thank you. Thank you for taking the time to be here. Quick show of hands. Is this session the first time you're attending an NSX session? Quick show of hands. Okay. All right. So my name is Milind Desai. I'm part of the product team working on NSX, and later today we'll be joined by Kausam Kumar, who's also on the product team. In terms of this session, we will talk about where NSX is today. This is in context to the fact that NSX was launched 9 months ago, and through that period we have understood how customers are using this product, what they're using it for, and so it will give you an idea of both features and functions, but also how people are starting the journey with NSX. What we are doing with our ecosystem of partners, and what are some of the myths that you may hear about, or things around operations that you may hear about that I wanted to kind of get into a little bit more detail. So if you look at the flow, we'll do an introduction to NSX, and then walk through the rest of the topics. So NSX. So before I go about talking why NSX, it's important to understand our thinking as we built out this platform of what we are trying to solve. So if you look at mega data centers like Google, Facebook, Amazon, over the past decade, they have proven out a model of software control over a repeatable infrastructure. The economies of scale they have received as a result through OpEx and CapEx reduction, but more importantly, the agility that they have received has helped them catapult in their business objectives. Now, they can do this because of two things. They own the application, and they have thousands of programmers. You, as IT, don't own the application, and we don't have thousands of programmers. So when VMware talks about SDDC, and we are in reference to SDDC, a key component, we are trying to bring the same model for you for any app that you deploy over a repeatable infrastructure of your choice. That is what software-defined data center enables for you, and NSX is a key component of it. Now, the net result is the same benefits operationally, but more importantly, the speed of business, right? The ability to bring things faster, to bring solutions to help your end users faster is the net result, the same objective that mega data centers can achieve today. So let's take a deeper look at NSX. NSX enables network and security services in software with policy. So let's walk through some of these services. Switching. Think of it as, we know VLANs, right? We have to go provision VLANs, touch physical switches, make it happen. Imagine a world where you have 3 vSphere clusters, you prepare them with NSX, and you say, I need to create a new L2 domain, a new switch for a new application. And to be able to do this without having to touch anything on the physical network, right? It's an overlay network that allows you to create a boundary for your application. Routing. 2 VMs sitting on 2 different networks, your web tier and your app tier. They end up on the same host, same hypervisor. They talk to each other directly. They don't need to go out and come back in. East-west routing, fully distributed. Firewalling in the hypervisor. The security policy is enforced at the hypervisor, fully distributed. We have other functions like load balancing. to enable you to do cloud load balancing with NSX. VPN, if you're remote connecting to a cloud like vCloud Air. And then bridging if you're bringing physical assets into logical space, right? So if you have a physical workload that needs to connect to a logical switch workload, you can use the bridging mechanism. All of this is done in software through an API or a UI. The UI sits in the vSphere Web Client, and you can do this on top of your existing infrastructure. No change. Physical network that exists today, your vSphere clusters as they exist today, you prepare them with NSX, and you can start deploying these services for existing workloads or new workloads. So let me be clear. Let's say I walk into an environment, you have vSphere 5.5 running. You give me 2 clusters. There are already workloads sitting on those clusters. They're sitting on traditional VLANs. They've got traditional services. You prepare them with NSX, and then drop 2 or 3 new workloads, and now they're sitting on NSX. Old topology, new topology, same infrastructure, right? You don't need to go build new things. Yes, for new opportunities you can, but this allows you to slow roll into your environment a technology like NSX. What this allows you to do is deliver the operational model of a VM now for networking and security. So what does that mean? You can create, delete, grow, shrink, secure, add third-party services to the network dynamically, again, without touching or changing infrastructure. Much the same way we can do for VMs, right? Create, destroy, shrink, grow. As the network grows, let's say you go from one vSphere cluster, you need more capacity, you add another vSphere cluster, the network grows, right? The workloads expand. Project is over, you shrink it, the network and security policy shrinks with it. You did not have to go and undo things or touch 10 different devices on the physical side. So it allows you the operational model of a VM, but for network and security, and as a result, helps you enable better agility with NSX. So let's take a look at the components. You've got the switching components that sit in the kernel. It's a fully distributed model, like I said before. All east-west communication is hypervisor to hypervisor, fully distributed. Scale-out forwarding plane, we'll talk about performance later, line rate. That is orchestrated through a control plane that is highly available. It's called the brains of the operation. It sits and decouples the logical topology from the physical topology, right? It knows where all the different elements are, and as a result, orchestrates the show. It's scale out and highly available. So if a node goes down, the other nodes take over. If you need more capacity, you can add more capacity. That is then managed by a management plane, which delivers an API and UI interface. And this is all provider side right now, right? And then you can automate and deliver self-service IT through a cloud management system of your choice. It could be vCloud Automation Center, it could be build your own, or it could be VIO, or some other iteration of OpenStack. So the components look great. How do they fit in from a practical standpoint? So what you see over here is, it's not a reference design. We have reference designs, but what I wanted to show you is how do the components fit in. The management and control plane sit in the management cluster. Most of you are aware of the term management cluster. This is where you put your vCenter and other management solutions for your data center operations, right? It's virtual VMs. You put them in the management cluster, which is right there. Now you want to deploy an app, or it could be an existing app, but let's say you're deploying a new app, the workloads will sit on your compute clusters. It's multiple clusters. It doesn't have to be vSphere cluster bound. It could be across 6 vSphere clusters for that matter. Wherever capacity is available, you can deploy that workload. And that box that you see is delivering that east-west distributed services capacity for that workload. Logical switching, logical routing, logical firewalling. In this model, the web and app VM, when they want to talk to each other, nothing leaves the hypervisor. I have a security policy that says web layer can only talk to the app layer on a certain port or protocol. That is implemented in the hypervisor. And it was all dynamically instantiated when the workload arrived. Right? All east-west communication is fully distributed. And then when you go north-south, you go through a set of nodes called NSX Edge. That is available as active standby. And in 2 weeks, as we go GA with the latest version, it will be available in active scale-out. So for north-south, going from logical space to physical space, right? That's when you go through those nodes. So those are the components, as you see, the management plane, the data plane, which is fully distributed, and the NSX Edge, which goes north-south. Key points, distributed topologies, dynamically instantiated, right, through a central API UI in that regard. So this is kind of the offering. What does this mean? So since last year, we talked about NSX on stage, and there were jokes about how it was NSX World last year, and it was great. While we were fixing and building new features and product, one of the things we focused on was training and certification. And why is this important? Because as you embark on this journey with us, you're going to bring your colleagues, maybe network and security background. There are some folks who are compute background who want to expand themselves to become network and security domain aware, right? It's the SDDC. We're going to expand our role and scope together. And so we now have training courses like an install, configure, manage course. It's a 5-day training course on NSX. There is as you can see, if you're a networking person, there's a networking course that makes you a little bit more virtualization aware, right? And if you're a virtualization guy, there'll be a little bit which will make you more networking aware from the basics of the solution. And we announce certifications because that is important as you embark on this journey with us. So there are 3 levels of certification, including VCDX NV, which is the highest level of certification for network virtualization. And we have CCIEs who are participating in this framework. Network folks are helping drive this change in large and small accounts. And they are embarking with us on this journey, and there's a path for them to participate in the SDDC alongside you. Common question that gets asked. Where are the design guides? Where are the reference guides? So you can see that we have design guides for NSX from us. We are creating hardening guides, just like you have hardening guides for vSphere. But we are also starting to create solution design guides with our partner ecosystem. Right? Palo Alto Networks, other security vendors in that regard. You've got Arista, Juniper, Dell, and other vendors. Now, the question is, there is no Cisco. Right? So NSX works on Cisco networks, right? If you're buying the 9300, it works with the Cisco network. Not a problem. And we do have reference design guides that are being built that will show you how to apply these principles on a Cisco network. These are the ones that are working today, right, in terms of the documentation. But we already have reference guides with the 2K, 5K, 7K model, and more is coming. Because that's what happened in my last session. Somebody asked me this question, why was Cisco missing? NSX works with Cisco networks. In fact, the majority of our customers right now, because we work with existing infrastructure, are Cisco customers. We are not a product. We are a platform. Think about it this way. We are a platform that will transform data center for the future, for the next N years. And this is just the beginning of the journey, right? Things like distributed routing, distributed firewalling, concepts around security that we're thinking about are going to forever transform how we think about network and security in the data center. And we are not doing this alone. So we are partnering at a deeper level with physical device vendors. We are partnering with operations vendors. We are partnering with, what I call as advanced networking vendors, folks like F5, and security services. Security services starting from firewalling all the way down to vulnerability management. And this is just the beginning. We've got startups who are building solutions just for NSX. This is a platform, and this is a journey. And we're going to innovate with our ecosystem to transform how we look at data center networking and security going forward. And this is just not a logo of slides. The folks who are not grayed out are shipping solutions with NSX. Right? So it's not just a logo slide. These vendors are now shipping solutions with NSX. I could build products, I could write guides, I could bring the ecosystem. It doesn't matter until somebody uses it. So it's been, I would say, 10 months, 150 plus customers, multiple customers who are deployed in production. I'll give you some examples. USDA is running a self-service IT cloud with NSX. You've got Umpqua Bank, who is using microsegmentation with NSX right now for their most critical workload. And you've got service providers like Racks as well as Colt who are using it to enable onboarding of their customers into their public cloud. So it's the whole gamut from self-service IT to data center automation with microsegmentation to a public cloud offering. And you can see there is not one specific vertical, it's across the board. And of course, you heard from Medtronic on day one about how they're embarking on the SDDC journey with us, and NSX is a part of that journey. So let's look at the use cases. And we did talk about these use cases last year. And fortunately, the use cases have not changed. So let's deep dive a little bit into what each one of them means now, because some customers have now started embarking on this journey. And the first question I get asked is, technology is great, where do I get started? How do I get started? So let's look at self-service IT. So the consumerization of IT, everybody talks about it. I'll share an interesting conversation with a customer. He comes to me and he says, I wanted to set up a music system at home. Streaming, plays my MP3s, my TV is connected, every room has a music player in there. I can play different points of music in different rooms, inside or outside. I said, okay. He said, you know what? I woke up Saturday morning, bought Sonos speakers, downloaded Spotify, uploaded my MP3s to Amazon Cloud Player, connected my TV system to the Sonos Play Bar. 3 hours later, I had connected my whole house. Any music in any room of your choice, satisfying all the things I wanted. Why can't I have that kind of automation and agility at my workplace? I was like, that's a great point, right? Folks are taking their day-to-day experience at home and how simple it's become to access things. Home alarm systems can now be orchestrated from your phone. I just installed one, and it's pretty crazy, right? So people are saying, why can't I get some of the same experience with my enterprise IT? The other thing that's happening is, as we talk to business leaders, and I'm on a plane a lot, and they say, they're concerned. They're concerned with the status quo, and they're saying, it's no IT or new IT. And I want to be new IT, and how do we make this happen together? Right? So when people talk about self-service IT, it's very important that it's Not some sort of, hey, we are not, it doesn't apply to us. It is, these conversations are happening, and they're coming from the end users. So let's take a look at this, right? It's about deploying the app. It's as simple as that. The apps turn into VMs, 1 or 5 or 10. They could be arbitrary topologies. If you look on the left, that's how apps were built before. These days, people talk about taking apps the way on the right-hand side. You've got things like PaaS. You've got things like containers you heard about on both keynotes. They all want it now. They want technology, and they want it now. And the good news is that we do have direct integrations into cloud management systems that enable this. You could go to a vCloud Automation Center portal and create that complex topology and deploy it today. You could go to OpenStack and deploy a topology today, right? That is what our customers are doing when we talk about self-service IT. The question is, how are you going to get started? So that's where I've tried to project the conversations that we've had with customers into what I call as a journey slide. The simplest way to think about this is on that infrastructure that you have today, your existing infrastructure, we deploy NSX, we take a few nodes, and we say we want to try self-service IT. We want to take a use case, I'm going to create a small dev test environment in there. And what you do as a provider is pre-create the infrastructure. So it's all logical, but it's pre-created. You put it in a blueprint. The end user comes in and says, I get 5 VMs, 8 app VMs, 10 DB VMs. It's all pre-created, gets deployed. Success. Step 1, that's success, right? You went from not having any kind of self-service to self-service with a little bit of pre-creation. Some of our largest customers started at that point. They started with the notion that I'll pre-create stuff, I'll show the templates, and folks will deploy VMs on top of it. So it's not dynamic, but it's provider control. End user doesn't see it, he sees agility. If you think about it, where we go from there, and this is where most customers are now thinking about, is what I call templates. You and your team design those app templates. It says that when this template is instantiated, it will create a NATed profile or a routed IP profile. It will have security group X in that regard. Nothing is created, it's just a policy at that point in time. End user comes in, looks at the catalog, says, I like that. I'm going to go in, 7 VMs, 9 VMs, 10 VMs. Okay, done, deploy. Everything is dynamically instantiated. In the first one, you went from probably 6 weeks to 3 hours. 3 hours because you're still pre-creating some of the stuff. It's not really 3 from the end user standpoint, but I would say 1 to 3 hours from your standpoint. In the second one, you design, you give the templates, you stand back and let it roll. Minutes. You're not involved in the life cycle of your developer deployment. They get what they want, and you're watching in the background, operating this environment in the background. The last phase, if you decide to go to that phase, is to create what I call as small playgrounds as a provider, and end users come and create arbitrary topologies. It's like, I want a switch, I want a router, I want to create my own firewall rules. That's like full self-service. And very few customers with extreme desire and extreme needs around DevOps, like true DevOps, are going to that model. So a lot of our customers are sitting in 1 and 2, and then you've got that 3. So my point being here is, same infrastructure as today, we pick a use case, we deploy NSX on the nodes, we have compute already, we can start this journey together today. And you have to take a starting point. In this case, you could start with some pre-creation, go to dynamic, and may choose to go to full self-service to the end user. Let's take a look at data center automation. So why do I call it data center automation? Because there are many things, but one of the biggest use cases in here is micro-segmentation. So let's take a look at this. You've all seen many different versions of this, the hard shell, the GUI interior, and all of those things. The basic essence is that most of the attacks that are taking place right now are coming from the inside. I get in, I have access to almost everything. We are hyper-connected inside, right? You have protection outside, but when you get in, there is no lateral security. Why? It is very expensive to implement, and it's very difficult to operationalize. The expensive piece, you could get away with. It's security. We've got to spend it, right? The operationalization is very, very much problematic. So what you can do in regards to NSX is, because you're sitting closest to the application, you can now start creating smaller zones based on a VM, an app, your group of apps, or all of the above. Right? You could not do this before. Security closest to the application, aligned with the application lifecycle. Every app becomes a data center. I'll repeat that. Every app becomes a data center. You're securing it in that manner. An example of how simple this can be. How many people here have view workloads in their environment? A few of you, right? I'll take that as an example. Or let's take a DMZ, right? Let's take a DMZ. I create a DMZ policy. I have a perimeter firewall. It's not gotten rid of that, right? It's still there. But I have a DMZ policy which says no VMs in the DMZ can talk to each other. The DMZ can only talk from the outside world on coming in from external network 25 on port 443. And it is only connected to internal network 36. I create that, and as VMs arrive, they auto-inherit that policy. It's dynamically instantiated. The policy is as simple as that. And your security team can do it, you could do it, and it's compliant with all the classic syslog integration and everything else that comes with it. Right? It's as simple as that. But you could take it a step further with our ecosystem. In that DMZ, not only will I say port 443, I say take that 443 traffic and send it to a Palo Alto Networks appliance for protection for layer 7. And I would like anti-malware detection enabled in that security group. And I want vulnerability management in that regard. So it's not just security in terms of classic layer 2 to 4 firewalling. It's the whole security ecosystem that is being enabled by this policy. And you can write this simple policy and everything gets dynamically instantiated, including the partner solutions, right? So that is what we mean by microsegmentation. And this is what is catching the interest of our customers, because you can take your existing workload sitting on an existing physical network, and without having to think about changing networks and VLANs and this and that, I could slide in and give you this model today, right? You're not going and starting to build logical switches in that regard. You're going with your existing workload sitting in your existing network, right? And we are now going in and sliding in NSX security. So from a journey standpoint, this is the journey we are seeing in some of our customers. Once you do that, at some future point in time, as you get comfortable, or as new apps arrive, you go to the full model. Now your natural question is, Milind, why do we need to go to the full model if I'm getting all this security? What did we start with? Reducing the attack surface. You're still sitting on a VLAN. Yes, I've secured you, microsegmented you, but you're still sitting on a VLAN. Think like a security guy now. They don't like, anything to talk to anything, right? What if the app gets its own address space. Within it, you secure it. Every app is its own address space. This is why the final step of the journey is important. There are no shared constructs. I sit on my own broadcast domain. Every app has its own domain, and nothing I'm sharing with others, right? So you can start this journey with your existing constructs, and as you progress along for new apps or for existing apps, go for the full network and security virtualization element in that regard. So that's the customer journey. We've got multiple customers doing this in production now, and that is what, you hear about microsegmentation. That's what we mean by that. So, what I thought was, since you've heard so much about it, I'll have Qasim come and talk you through a simple demo of how easy it is to enable this solution.
Thank you, Milind. Before we get into the demo, what we're basically trying to show here is how you can operationalize microsegmentation. Even before we get into microsegmentation, what do you mean by microsegmentation? Everyone talks about it's inside the data center, it's east-west traffic. As a security guy, what are you really thinking about microsegmentation? And most obvious answers comes from the customers is, I care about the app. That's one app. I want a firewall rule on that app. I don't care about the perimeter at that point. This app should not talk there. This app should have this much AV. This app I should do network introspection. I don't want to do network introspection on that app. I want to do it in this app. And you know the old saying, right? Prevention is better than cure. That is what it is. You basically expose as much attack surface as you want and not more. That is what microsegmentation means. So let's look at this demo. And the demo is basically, I'm going to take the most simplest use case. Every organization has it. A development zone and a production zone. We're going to show that first, and then we'll go and see how you can use built-in services like distributed firewall, how you can use third-party services like Symantec, Trend Micro, PAN for all your network needs and security needs. So let's start. So the first thing, the screen, we're going to go into the Service Composer. The Service Composer is basically your
Go one step back. No, one step back. No, yeah. You have to use the mouse.
Yeah. So the Service Composer is your basic screen. What do you see in the screen and what do you not see in the screen? What you see in the screen is two zones. You have no idea what they are in the zones. I'll explain it to you what is there, but what do you see? You just have two zones. You don't worry about what network, what infrastructure, what anything. You just have two zones. That's it. And that's what you want from a security perspective. Just two zones. Now if we look further, what does these zones have? Each of these zones have their three-tier applications. If you look at the production zone, it has web servers, application servers, database servers. Think about it. Every zone can have its own set of tiers. You can have 2 tiers, multi-tiers, 1 VM, anything. You can create a zone, abstract it out as you want. You don't care what the underlying infrastructure is. Because what you're caring about is the application. That's what you want to protect. That's what you want to show on the network. That is what microsegmentation shows us. So let's now deep dive into production zone. That's the one we want to really protect. Once you click on production zone, you'll see those subzones in it. Let's go back a little bit. So in this, as you can see, I can subdivide it into 3 zones further. I can have a web zone. Again, I can have web zone. I can segment it out to application zone. And I can segment it out to database zone. Now, what I want to really do is the web server is actually talking to the outside world. So I want to control with a different set of policies compared to what the database server is going to talk to. So I want to have policies which are specific to it. But think about what we showed before. I still have the production zone and the development zone. I don't want my production zone to talk to the development zone. How do I create policy? What do you do today? You have to go to each of these zones if you have created zones somehow, and then you have to write rules for each one of them. I don't have to do that anymore. All I need to do is go one layer up, and for the production zone, I just create rules. I say, don't talk to the development zone. And all I do is write 2 DFW rules, distributed firewall rules. You know what's the difference between a distributed firewall and other firewalls are? The traffic doesn't get rejected at the network level. It gets rejected at the host level. You're not increasing traffic, unwanted traffic in your network. You have rejected it already on your host. That's what we are doing here. 2 rules on the production zone, and you will see that these rules get inherited on all subzones that you have created. No extra effort. That's how we operationalize it. That's how we make it easy for you to do it. We have created those 2 rules, and now just go back and apply it to the production zone. Now you see, these policies are inherited. The subzones have it automatically. I don't have to do it. It's as easy as this. Now let's move forward. What's the next thing I want to do? Let's hone in on one of those, the web servers, right? The first thing I want to do is on my web servers, I want to have a comprehensive policy. Now, as VMware, we don't create all these security policies. We are not security experts here. We have our partners who do it for us. What we are doing here is we are enabling the NSX platform so you can consume these services from one single management plane. This is one single policy that you're seeing on the screen. If you see on the screen, I can have an endpoint policy, I can have a network policy, and I can have a firewall policy, and that's one policy that I can apply to a zone. A zone consists of all the VMs in it, all the applications that you care about. So you can actually select 10 different solutions, have one pane to create one policy. In this case, we are showing how we want to do AV with Symantec, vulnerability management with Rapid7, and our own built-in DLP service for data at scan, or data at rest scan. Next, we already showed this with the production zone. You can actually create your own firewall policies. And what we are trying to basically do is, we did a blanket block all. Now we want to do a fine-grained policy. We can do that. We can select what service can talk to what zone. What service can be talking to this security group? What service can go out of this security group? Now, once we have done this, the last part is, if I want to detect certain specific calls, or I want to use our next generation firewall, some of our partners do that, you can go ahead and get Palo Alto Networks and just introspect traffic coming out of that zone. In this case, I want to inspect all traffic that comes to the web server from the internet. Or I can do one more thing. I can actually inspect remote procedure calls that go from the web server to the app server. I can do that. I can send the traffic to a third-party service, and they will inspect it and let me know whether I need to allow that traffic or not. That's the power of microsegmentation. That's where you're not just doing east-west traffic and lateral traffic control, but you are actually protecting your app for using rules which are specific for that app. Not more, not less. The right fit that you want for a zone, for an app. Let's now apply it. Now remember, for a zone, you can actually apply multiple policies. And you will see it. Do you see it? You have multiple policies. And you can select precedences. You can select inheritances with policies. So it gives you more flexibility in how you define what your rules are going to be. And remember, this is only on a zone specific. You don't care what your underlying network is. You don't care where your app is, which cluster, which host. If you vMotion it out, the policy flows with it. This policy that you've just created, you don't have to worry about it. Now, for people who are still interested in looking at firewall rules, you can still look at firewall rules. All the rules that you have created are still there. Your old way of looking at screens, you can still see it. It's there. It's sectioned out with the security groups, all the zones that you have, so you have one consolidated view that you can look at. Now, your question would be, how do I, sorry. So now your question would be, how do I know what services do I have on my ecosystem? We just have a single pane. It's called the service definition. Any service that NSX uses, whether it's built in, provided by us, or third-party vendors, it's registered at one place. There's only one type of deployment that you do. There's only one method of deployment. You don't use multiple methods. You don't play around with multiple consoles. There's just one place. You deploy it. You see the status. You know what's up, what's running, and how you're going to protect it. That's the platform power that we are providing. I'll hand it over to Milan.
Thank you. So the reason we wanted to walk through this demo is we've talked about like microsegmentation a lot and wanted to kind of walk through what that really means, how you can set it up. The interesting thing about this is the conversations are actually happening with security folks. So as you go in, you go back, and there's a conversation around security, bring them on board. In fact, a lot of the championing of NSX right now in organizations is happening when the security teams realize the power of this product, right? So it's not that you have to do this journey by yourself. You can actually bring together the security folks who've been sitting on the side into this journey with you. WestJet, Umpqua Bank are all examples of customers where the security team has embraced NSX wholeheartedly. All of this can be fully automated through the self-IT concept that I talked about. Through a vCloud Automation Center construct of vRealize Automation Center, you can provision a workload into one of these dynamic security groups. So, in the last 9 months, and it's, for a lot of you, this is the first time with NSX, so what's new won't really matter. So I'm going to kind of quickly walk through some of these concepts. But we have made, in the last 9 months, significant enhancements to the product. The one myth out there is NSX only works for vSphere environments. That is untrue. NSX works in a multi-hypervisor environment. We continue to contribute to this framework called Open vSwitch. We are the leading contributors, and we continue to improve the product and optimization of that virtual switch, be it on KVM, Zen, and now working with the community on Hyper-V. NSX Edge, remember I talked about active standby? Now you can go active-active, 8-node, in and out, and it works. Physical device integration talks about the ability to integrate physical top-of-rack switches into NSX. So what does that mean? I told you that we work with existing environments without any change, right? It was just like server virtualization. When it first came in, it worked with all the servers. Then Intel came with VT, and we took advantage of that. Think of it that way. We work with any network that is out there, but as network vendors are realizing this platform, we are starting to build integrations where we can work with them and offload certain functions to them. That is that integration which is called physical device integration, right? And we'll continue to innovate on this front, just like you saw on the server side before, right? So it works with the stuff you have today. You don't need to offload anything to physical, but we are starting to integrate physical devices into this framework, into this platform. There are enhancements across the board. The one that gets me most excited is load balancer as a service. The ability to provision not just our load balancing instance, but also a partner load balancing instance, right? Through the same API, you could provision an F5 solution now as part of the application lifecycle. That's the work we are doing with F5 and other ecosystem vendors on this front. The multi-site and hybrid cloud enablement, if anybody here is thinking about using vCloud Air, and you have a requirement to burst to vCloud Air and keep layer 2 connectivity, you can now do that with NSX. A layer 2 VPN into the public cloud. It's very easy and it's very simple to use. If anyone over here has a requirement to pool 2 adjacent data centers, data center 1, data center 2, right next to each other, and make it a common compute pool, you can now use NSX to create that common compute pool across 2 sites and make that work. All of these enhancements have been made in the past 9 months. SRM comes up a lot, DR, it's top of mind for everyone. In 4 to 6 weeks, we will release a DR validation guide with SRM of how the 2 solutions come together. Big thing I talked about, you do self-service IT or you do microsegmentation, there are people who do operations on your team. How do they fit in to this framework? So a whole host of announcements with tools that folks use today, right? The most exciting part of this is the vCenter Operations Manager integration, which now gives you visibility into virtual plus physical, gives you logical topology views and other things. And the integration into Log Insight, which is, think of it as your own operations management tool for the SDDC. So with that in mind, let's, and then for consumption, deeper integrations into vCloud Automation Center, which is the next release that's coming out, or vRealize Automation Center, I apologize, and OpenStack, right? So you heard a lot about, OpenStack support for vSphere. NSX supported OpenStack for the longest time. We continue that support. We continue to lead that effort. This is a focus area for us, and you have an out-of-box integration, NSX plus OpenStack. Net, through customer conversations, through our own planning, a lot of progress has been made, right? This is the power of software and the ability to bring innovation and change at a faster pace. I thought it would be cool to see a demo around operationalizing NSX. Why is this important? Because when you look at NSX, there are tools that you will use to troubleshoot NSX. There are tools that your network team cares about when they look at NSX. And what happens as a result is you can plug into existing systems, NetFlow collectors, flow monitoring, and other things. And you can do deeper analytics through things like vCenter Operations Manager, as an example. The net is a demo, which now Cosmo is going to talk through, which shows you how you can use analytics with a platform like NSX and make troubleshooting very easy in the SDDC.
So why do I want to look at it? Why do I want operational flexibility and visibility? I need to know, this is after all a network virtualization layer. What I need to know here is, does my packet really reach the other end? But I don't want to look at each and every packet. What I really want to look at is, does this application, is it talking to that application? In my entire ecosystem, what is the current problem? How do I visualize that there is a problem? I can create all these distributed routers and logical switches. How do I know what path is it taking? That visualization, those tools, the NSX platform provides that information, and what we are going to show you is the vCenter Ops Management tool that we have integrated with it that visualizes that information for you. That is what our demo is going to be about. So the first thing in the dashboard, this is a vCenter Operation Management dashboard. You can look at the alerts. You can look at the transport layer. The alerts will tell you whether your edge is not working properly and what is not working properly there. You can see controller, you can see the NSX controller. It gives you an alert. No syslog server is configured. You want syslogs. You want it to feed it to your SIEM tools to analyze further. That level of information we provide you. And VCOps is just one of those integration. You can use any third-party tool who have integrated with us and get that same level of information. We can also show you what resources are there, are we compliant or not, what is the criticality level. All this is available, and the NSX platform provides you that log information today. The second thing is the transport layers. All the transport layers, you can look at the health today, colorfully as well as in numbers. What's the next thing that you want to look at? You want to look at how much traffic is passing by. I mean, it's a basic flow monitoring. You look at it and you realize, why is my app talking so much? That's your first level of indication. We give you that kind of analytics here. We tell you that this application, this VM is sending out so many bytes. We also, not just from a VM level, but for the network purists, we actually show you the logical networks and how much traffic is going through those networks. You can see the app, and you can actually look at the topology. If you just open a VM and navigate and go to its topology, you can see two things. Sorry. You can see the logical topology as well as the physical topology. Why is the logical topology important? After all, it's a network overlay. That's what network virtualization. You want to see your logical switches, your distributed routers, everything. You want to see how it's connected to the other tiers, other switches, other routers, how it's connected to the edge. So we give you from an app perspective, from a VM perspective, what's the entire distribution. We also show you what the physical connectivity is. How is it going out of the host? How is it going out of the cluster to the actual physical switches? Both of them are visible together in one diagram, in one screen. And you can take a look at it and immediately see, okay, maybe I've configured it wrong. Maybe my day 2 operations, something I need to add something more just based on how much utilization is happening. That's the kind of information is available from NSX today. Now let's look at one of the operational scenarios. Your biggest one would be, I have this one app, one VM, it is not able to talk to this other app. That's your biggest thing, right? So the first thing we can go is search for that app. Sorry. And then we basically show the logical path. How is that VM talking to the other VM? What are the hops is it going through? Is there a problem? Graphically, is there a problem on any of those hops? If yes, can I double click it? If I can double click it and see the error, it solves half the problem that I have. Okay, I can now focus on a specific area and then look at that area and say, okay, what do I need to fix here? And everything we show it visually, and the platform gives you that information today. Similarly, not just logical paths, we can actually show you physical paths too. You can see how the physical routes are happening. If you have a data center, in a data center, huge clusters and huge isolation, you can actually see the physical hops and say, okay, is my physical switch? It not just helps visualizing what your virtual packets are going through your overlays, it helps you on your physical network too. That is the power. Last, we'll look at one of the alerts, and we'll see that there's a logical router giving an alert. You can double click it and see what alert it is, how important is it. And these alerts, you can get monitored. You can be told that there is a problem. You don't need to sit on the screen and wait for it. It will be notified to you there is an alert. You can double click it and actually go to that specific component and actually look at what the alert is, what the errors are. So this is what we provide from an ops management and visibility perspective.
So why is this important? We're talking about intro to NSX. Why are we talking about operations? At the end of the day, as you deploy the solution, you've got to operationalize it in your data center. You're going to work with different teams and different factions, and how do you operationalize this across teams, right? So this demonstration kind of walks you through one of the examples using a tool like vCenter Operations Manager to make that possible. Integrating with physical, if you have physical workloads that you want to connect to NSX, you can do so. We have a concept which I talked about, the bridge, the software bridge, where you can take a physical workload and connect it to a logical workload on NSX. This is also where we have started working with an ecosystem to offload that functionality to the top-of-rack switch as an example, right? This is what I was talking about. It works with existing stuff because we have software offloads, and then like the Intel VT type scenario, we are starting to do deeper integrations, and this is the integration we are doing with physical devices around that. NSX works in virtual and physical device situations today. So x86 bridging, you've got the ecosystem support, and if you do decide, because there are developers in your community that they want to use concepts like containers, it already works today, right? I want to make sure containers running on bare metal or in a VM work with NSX today. Performance. Software doesn't perform. We don't know. You always need hardware. You need ASICs, right? That is not true. If you look at these numbers, and there's a specific session, you can look at those slides, as you go offline, go home. The numbers for switching, routing, firewalling, bridging are all numbers that are well in line rate as you look at different packet sizes and throughput. Right? So this concept of you can't operationalize it, it doesn't work with physical, it doesn't perform, is all just talk. We have customers deploying this in production, operationalizing it today with confidence, and there's data now to prove that. So in closing, the data plane, it's multi-hypervisor, including physical. Our focus is distributed services. We've started with some of our own, and our partner ecosystem is building it with us, with full automation, management, control, and data plane. A rich set of operation tools from us, as well as our third-party services, an API and UI that is fully integrated into a cloud management platform, enabling self-service IT. What this allows you to do, this platform with SDDC allows you to work on any network, the network you have today, 2-tier or 3-tier, or the next network design that you build for a greenfield, which could be a leaf spine, a layer 3 design. It just works over any infrastructure. Why do I say any infrastructure? In 2007, 2008, we were all building our own infrastructure. We would bring a switch from Cisco, a server from HP, and we would put it together, storage from EMC. Then we had convert systems come about. You didn't have to change anything when you looked at virtualization. Now you have hyper-convert systems coming in. Who knows what's next? Right? You need choice so that you can switch out the underlying physical infrastructure as things change and as innovation happens at that layer. And you want a solution that can work with any application. Right? Today's apps, PaaS, containers, who knows what's next. NSX with SDDC enables this paradigm. Choice at the infrastructure, choice at the network, and choice in terms of application design frameworks that you and your customers, your end users can use and deliver automation and agility in the data center. With that, we're going to close it out and open it up for questions. No questions?
No. No, he has. Yeah.
What is the minimum?
Can you go to the mic and say?
The minimum number of appliances necessary to create a test or lab environment? It's the NSX Edge, the controller, and the manager?
That is correct.
That's the minimum, 3.
3.
So there is no need to have an appliance in each of the ESXi servers that I have in my infrastructure. And those 3 appliances can be run on the management cluster?
Yeah.
Okay. And how does vShield Manager ties to this? They are complete different.
Two separate things. If you're using VCNS, you can upgrade to this platform, and
So
we'll transfer some of the constructs from there.
It's like in the future, vShield Manager and all those appliances would be deprecated in favor of NSX, or they continue to live on?
NSX is the go forward in that regard.
Okay, thank you.
Just replace VShield?
Yes.
It can.
Yes. Yes.
How difficult is it to convert from the regular switches that we have now onto?
Do you use the vSphere distributed switch? You're ready.
We're ready?
Yeah.
Just add this on.
Yes. Absolutely. Absolutely. Yes. Yep.
Uh-huh.
It is easy.
The gentleman there.
Your VPN solution, what types of VPNs do you support? SSL, IPsec?
We support both IPsec and SSL.
SSL. As far as the advanced security services, I noticed that you rely on third party to bring in more advanced features such as IPS and layer 7 awareness. Is there in your roadmap in the future to bring those services right into NSX?
Think of it as we are a platform and we are building base engines in that platform, and so it's a roadmap question. I can't answer it publicly, but the general idea is that we're going to enable this ecosystem and provide it with more context. So rather than build an IDS IPS, what if I took application context and gave it to it, right? So that it became more application aware from that standpoint.
Got it. Thank you.
Those antivirus and IPS modules, what actually does the computing power on those, and how does it impact their performance?
You want to take that?
Yeah. So the first thing we do, and this is one of our sessions, we basically, what do you do today? You have the agent installed on every VM. We offload that off. You don't have to do it anymore. When we show the deployment, they just deploy one VM. And that's the one that's going to do. So we have offloaded out. Your VMs don't hog any resources after that. Everything's on the SVM.
And that has storage savings also, because you're no longer patching in signatures on the storage side.
So in summary, we're not just changing some engine or making it operationally feasible. We are actually improving the way you're doing things. And that's what we are doing. Like, for example, a vulnerability scanner traditionally is a network-based scanner. In our model, it's actually a file-based scanner.
What about the performance of all the traffic now has to be sort of routed to this VM to do antivirus? How does that?
Yes and no means we've got, if you take like the agentless anti-malware as an example, for like a VDI type workload, you will see like hundreds of VMs on that host, and we've not seen any performance issues from that standpoint.